we were able to practice what we've been doing so far. How many of us were able to um, practice what we've done so far? If you were able to do that, just raise your hand. Nobody?
Hello, sir.
Yeah, hello, sir. I can hear you.
Yes, I was able to practice, but I have some problem.
Okay, all right.
So sometimes this an encoder this thing used to say, I mean, the Jupyter interface used to say connection failed, not connected, and error. What do we do when we encounter such problem?
Okay, so like the kernel itself tells you there's an error, right?
Yeah, we say connection failed or not connected, and at times it will bring error. So those three encounter, I don't know how to solve them.
All right. I hope you can see my screen like this, right?
Yes, sir.
Okay. So let's say, for instance, you click on this file and you want to open it. Then by the time it wants to open, it tells you error or it tells you connection
No,
failed.
maybe you are working. You are
Something like
working
this.
and so, error, no, not like that. Maybe you are working on your Jupyter notebook, and suddenly when you are about to run a query, it's now telling you that there's connection failed or not connected.
Okay. Okay. I think I might understand what. Sorry. Okay. So. Something was happening to my file. Sorry. Okay. So when that happens, so let's say let me create a new. So when that happens, what you should just do is you should come here. You should come to this refresh the kernel, restart the kernel basically, and then just restart it. So when you restart it, you can continue to do your work. There won't be any problem. It must have been that there was probably a code that you were running that was taking so much time, and then it affected the system itself. So that could have been one of the reasons why that happens. But whenever that happens, just restart your kernel, and that would be fine.
Okay, sir.
All right.
Another question, sir.
Yes.
When you wanted to import the sales data into the this PD into the when you wanted to import sales data the other time, you imported
when I wanted
it
to
from,
import it.
yes. So when I wanted to import it, I encountered a problem because I saved it into a folder in my desktop. So I don't know how to import it, and I use another name to save it because I have a sales data that I formerly used to use on Power BI. So that is why I save it differently. So I don't know how to get it from the folder. I was able to import from the web.
Which folder?
You know, you get.
You were able.
I was able to import data from the web successfully. But when I wanted to import that sales data, because when I downloaded the data that you sent to us, I now save it inside the folder on my desktop. And I use another name. I use a sales data Python class. I use it to save it. So I don't know how to import it. It was giving me some kind of error. I don't know how to do it, sir.
Okay. Okay, so when you want to import, please give me 1 minute, please. Okay. So when you want to import data from anywhere you have it, so one of the first things that you should do is that you should make sure that the data you have is inside the same folder that you have. Can you all see like my laptop screen, right?
Yes, sir.
Okay, so you see that this sales data that I shared with us, I have it inside the same folder where my Jupyter notebook is sitting. So whenever you download your data, so let's say you download the data and then you have it inside your download folder here. You should first copy the file or move the file that you have, the data that you have, move it from wherever you have it inside your download folder and move it to the folder that you'll be working with. So when you move it there, you can easily run the the code to sorry the code to um the code to read the file that you have imported basically. So that way it's very much easy. Although there is also another way to read files that are not sitting directly on the same folder, right? So when you don't have, so let's say you have your Jupyter notebook file here, and then you have a data file inside your laptop somewhere, and you don't want to move them to the same folder because, so let me show you something. I have some data sets on my laptop, like quite a lot, and so these are all data sets, like data. So you see some of them in CSV, some of them in Excel, even some of them like in inside folders. So if you want to, let's say, read files that are inside your laptop, but they are not inside the same folder as the one that you are working with, there is also a way to read that. This is basically the way to do that. Let me just show us. I have done something around that. Okay, yeah. So you can just use, so Python has something called the read function. So it's not like a function that is inbuilt, it's just some string manipulation system. So you see, for instance, here I have pd.read, and I have r before I then have like the location file path, the location of the file that I have inside my laptop. So you see it goes like c.user/del/desktop. All of this pathway that I have up until this data analytics are all how would I call it, are all configured in the structure of my own laptop, which is not the same as your own laptop. But what you just have to do is you just have to include this R and then copy the file path. If you want to copy the file path, what you should just do is where your data is, come to this top and click on it. You see that it shows you a file path here. Hope you are following. So it shows you a file path here, and then you can just copy this file path and then add your file name at the last with the extension that you are working with. This way you are able to import the file with the file path that you have. Also, the good thing about this is you can easily use it what's it called, you can easily use it on your laptop. But the bad thing about it is if you give somebody your code to go and use, the person will have problem with this file path because the file path is configured specifically according to your own laptop. So if the person's laptop is not configured according to your own, there will be a problem in reading this file. And if the file is not sitting inside the same folder as your Jupyter Notebook file. So that's why I said previously that whenever you want to read any file, it is better that you have the file inside the same folder, so that anytime you are giving your data, your code to anybody, the person sees that, oh, this file that we are reading is inside this folder, and you can easily read it. So that is that about that. So I figured, okay, so there was a challenge the other time. Let me explain what challenge I was facing. Okay, 1 minute. So something happened. I really did not know what happened, but my laptop, how do I call it? Edited what we have inside our pandas file the last time. So this p4da that we had, you can see that the file size is now 0. I don't know why, but I think 5 days ago, that was like on Tuesday, my laptop did something and it deleted the content of the file, but it created like how would I call it, like a temp file for it inside the same folder. So that's one of the reasons why whenever you are working on any project, it's always better you have them inside one folder. So if I'm working on, let's say, a sales analysis, especially even if it is for the same company or different companies, it's always better you have them inside one folder. That way you are able to monitor everything that is going on for each project that you are working with, and you can easily trace any issue. So I had to rename. So he created a temp file, which is this temp file I call fix. And this file now, all I had to just do was add an extension to it and then remove the temp attributes that was with it. So that was basically what I did to fix it. So we might probably face such challenge later on. It's just something that we can just change by just renaming the file and adding the extension that we are working with. That is that. So last week we thought we did introduction to Python, and we also get to use NumPy and Pandas. So today would be moving to the next part, which is visualization. So everything about visualization is what we'll be doing today. So we want to see the different Python libraries, how Python handles visualization. So and so we'll be joining our visualization with certain analytics. We'll be joining what I said, analytics, certain what's it called? Yes, certain analysis that we'll be doing. So for instance, if I want to visualize the stores, let's say I want to know which product sells the most. How do I know that in terms of just numbers, and also how I am able to visualize such thing? So that's what we're doing today. And I have created, so I'm going to, this fix, I would close it. So I'll be using this DAMP, still the same thing, just to have like a follow-up of what we are doing so far, so we don't create a new, or should we create, okay, let's do it like this. Should we create a new file where we have, oh no, creating a new file is a lot of work, because all of the cleanings we've done, we will do that all over again. So don't worry, what we'll do is we'll use this same file that we have, and then just continue with it. So, but what I would do is I would just call this file, I want to rename this file and say pandas and then plotting. So we have plotting. So I'll call this plots. So okay, then I want to, so what I'll be doing now is I would basically be running all of the codes that I have previously, one after the other, so I'm able to use it. So I have import pandas.
Hello, sir.
Yeah, I'm with you.
Good morning, sir.
Good morning, sir. How are you doing today?
Fine. What you're saying in essence is today's work is going to be built on the work we on Sunday.
Yes.
Okay. Because
So that way.
I was kind of not available that day. So that's the reason why I was asking. No
Okay.
problem.
Okay. Yeah. Okay. I think it's better if we can actually do it two ways, but I just want us to avoid the what's it called, the stress of going back and forth, back and forth. That's why I just want us to continue from what we did like on Sunday. But if we are bothered about the codes, like understanding the code and everything, I think it's not much of a big deal actually. But once we get there, I would just explain all of the things. But another thing we should do, I think we should actually have a new file. Yeah, let's have a new file. That works. I'll just what I'll just basically do is I'll be copying codes that we've used previously and then explaining them here. I think that should work. Okay, so we have created a new one, so I want to call this. So now we'll be having all of the libraries we had before, and we'll be using some visualization libraries also, and we'll be able to see how we use them together in terms of how they work. So first is sorry, I need to. Okay. Okay, so first is we import the libraries we want to work with, which is pandas. Then we import the other libraries we are working with. The reason why I'm not importing NumPy today is because we are not going to be using NumPy. NumPy does not have the what's it called, the feature of visualization, and also I already explained the connection between NumPy and pandas. As such, we will not be using it. So the other libraries we'll be working with include so the other what's it called, the other libraries we'll be using include Matplotlib. So we say import Matplotlib dot pyplot. So Matplotlib has different functions inside it, but the one that we want to use for visualization is called .pyplot, and so we'll call it as PLT. Now, like I said, if we look into all of these references and documentations we have here, we'll be able to see all of the documents, understanding how to use them. So if I want to look at how to use Matplotlib, for instance, I can easily come here and then understand all of it. So we can go through this guide for Matplotlib anytime we want to, and so we are able to see how it works, how to use it, and all of it. So back to what we have here. So we have import Matplotlib. Then also, because we are using Matplotlib inside each of the cells, like for each cell we run, it should run in it. So would be using something called percentage matplotlib inline. So so I'll be using this also. So what this does basically is it visualizes each of the plots that we have inside the same like in its line itself. So we would be importing Seaborn. So Seaborn is also another data visualization tool, library, sorry, I mean in Python that we'll be using. Lastly, we would also be using plotly.express. What plotly.express does is it's also a data visualization library, but this time around it is for interactivity. So you are not just able to visualize, but you can also interact with the charts with what you've plotted itself. We'll be using this also. So we'll call this dot as px. These are some of the.
Please come again. The reason why we're using plotly.express.
Okay, so Plotly itself is a data visualization library, but it's in its own feature. It has interactivity along with it, so you can interact with the visual that you have. So, for instance, how would I explain? I said, for instance, don't worry, when we get to where we are using Plotly Express, I would show us the difference in the way Plotly Express plots the charts that we have, and also the difference between Matplotlib and how Pandas plots. Because all of these libraries, they have their advantages and disadvantages. They have where they are being used. And the good thing is you can literally use some of this library together at the same time in the same chart. It's just for you to be able to understand what each of the library is doing at a particular part of the code that you have. So I'll run this. So when I run this, okay, it says there is a problem as px. So what's happening here? Let's see. Oh, I did not write import. So yeah, I did not write import here. So when I run this, it's going to take a while. It's going to load all of the libraries one after the other. So while it is loading, I just want to do something. So all of the libraries are running one after the other. Then once yes, I'm with you.
Why is loading? The line after the import matplotlib.pyplot. What did you write in between the import Seaborn and the matplotlib? Yeah, what's that?
Yeah, so it is percentage matplotlib inline.
So why the use of the percentage there?
So yes, in using the matplotlib feature, it's library itself, we have to, there is a, how do I call it? It has, the way it was developed is that whenever you are going to be using the matplotlib feature, you have to write the percentage matplotlib inline with it. So that is its own one of these, its own syntax. Let me put it like that. The way it was structured for anyone to use it. So that's why we have this there. So our libraries, all of the libraries are completely.
That Matplotlib inline as well.
What did you say?
Are we going to run that percentage under that Matplotlib something? Are we going to run that one as well, that percentage?
Everything runs together, so it's not like it is running separately. Everything runs together.
Okay.
All right. So I'll be back. All right. So we've imported all of the libraries that we'll be working with. So we have Pandas, Matplotlib, Seaborn, and Plotlib. So let me just okay, 1 minute. So we have all of this. Okay, so change this to this is a lot. Okay, this. Okay, so we have data visualization with Matplotlib, with can you hear me?
Yes.
Okay. Hope you can see my screen, please.
Yes.
Okay. So we have visualization with Matplotlib, and so but we'll be starting with Pandas because that was where we started from, and so I would be importing. The first thing I'll be doing is bringing in the file that we used last week. So I just basically will be copying the code so that I don't have to like spend more time writing. So we have this and then we run it. So now we have our sales data, the one we worked with, we were using last week. So this is what we have in it. So I'm going to be cleaning it. The next thing will be to clean the data that we have after we've done all of the, how do I call it? The first stage going through, or going through the data that we have. So that we understand what is inside our data. It's very important that even before we clean our data, we understand what is inside the data we have in the source itself. When I say source, I mean what is coming in from where we are bringing the data in. Then we also now understand the data that we have, how does it look like? Because, for instance, if we open the CSV file of the data that we have here, we would see here that this, our order date, is a date colon in its structure, in its form. But when we import our data and we check it on Python, we see that it is not coming in as a date colon. So that means that there has been a change in our data from us importing the data that we have in CSV into Python. All of this could happen in data because these are some of the how would I call it, challenges with working with data, where the data you have from the primary source is different from the data you have inside your database or inside where you are working with, where you would be working on the data. So this means that you have to pay attention to all of the columns that you have inside the data that inside the table or the data source that you are working with. So this is just one example. The reason why I mentioned date is because date is one of the most tricky aspect of data, because there are different formats for dates, there are different country style for dates, there are different date extensions. Sometimes you have dates and time, sometimes you have only dates, sometimes you have only time, and time itself you can be split into hours, minutes, seconds. Same thing for dates, months, day, and year. So we need to pay attention to this type of columns, because situations like this could affect the way you analyze your data if we do not undo our data cleaning process very well. And for us to undo the data cleaning process well, we need to understand the data that we have. So the next thing I'll be doing now is cleaning. So I'll be removing some of the columns that we do not need. So now we have 22 columns. after we've dropped address lines, states, and postal code. I don't want to go back to why we dropped these 3 colons, but basically there are colons that we don't need in what we were doing as at in our cleaning process. Also, the next thing that we had to do was to what's it called, to replace the null value on our territory, because if we go through the territories, you see that there are null values here. And so for us to undo these null values, we said that we should change the null values to NAM, meaning Northern America. So that would be the territories for all of the guys that have null values on that, all of the countries that have null values on their territory. We also did some digging to understand why we are changing this to North America. So we don't just, for instance, if there was a sales in Nigeria and the territory was null, and we just change everything to North America, that would affect our analysis. So we had to like dig in to see why. We did that last week. So we could just go, if we go through the data we worked on last week, we understand that. So we see now that our null value here has changed to Northern America with this. So the next thing we did was to now work on our dates. So we converted our dates from object type to date time. So before I run this, I want us to see what we have here. Our order dates is an object data type, right? So when we run this now, we are converting our order dates data type from object to date time. Basically, the function that is doing this is the PD, which is the Pandas function that changes the colon from whatever data type it is to date time. And so we run this, and also we said that we are creating a colon called order date. Now you would wonder, we have a colon already called order date. Why are we creating a colon that has the same name as the colon that we have? Basically, what Python understands from what I've just said is that everything that we had in the previous colon should be changed to this new function that we have. So it is going to override whatever name or whatever data is inside this colon that we had. So when we do this now and run this, we now see that our date that was in this format, in this date time format previously, where we have 2, which is the month, date, and year, with the timestamp, has now been changed to year, month, and day, which is the actual standard date format. According in programming, the standard date format, it should be year, month, and day. So that's like an hierarchical breakdown of the date time structure that we are working with. So Python already understands that. And it automatically converts that. So now when we check by saying sales data dot info, and we run this now, we will see here that our order date colon has now changed to date time 64, which is different from what it previously was, which is an object. So we see now that we are able to change the colon that we have. Now, the next thing we did was to go through all of the data, and then we removed the other columns that we feel like we really did not need. For instance, we saw that we did not need the customer phone number. We would not be performing any analysis on customer phone number. It is just an extra information which we don't need. And I also told us that whenever we are working on data, one of the most important things for us to take note of is the size at which the data we are working with is. So if we have unnecessary colons holding, we have colons holding data, but we don't need data for our analysis. The best thing for us is to drop them. The best thing for us is to drop them. But there is a culture. The culture is you don't drop data from your primary source. So take for instance, I have data coming in from a CSV file, and I have created a data frame from the CSV file. Now I want to work on the data. The good thing is that you have a copy of that data. That way, if there is any issue that comes up later on, you are able to go to the data frame you copied from, and you can easily recreate your data frame from that, instead of going back to the data source to start pulling data. Because when you go back to the data source to start pulling data, you are going to be wasting time. You are also going to be wasting space, because the memory that the system would be using to first delete the previous data source, the data frame, previous data frame that you had created, and then recreating another one is a lot of time and a lot of space. So instead of doing that, it is better to create a copy out of what you have. So how do we create copy? All you just have to do is say your data frame dot, when you run this tab, you would see copy as one of the functions that you can have. Although for us, because the data we are working with is very small, we really do not need any of these things in our in the data that in the analysis that we are performing, so we do not need it. But either way, this is the copy function, and all you just have to do is say sales data.copy, and you give it a name. So you can just call it sales data backup, something like that. So sales data underscore bk equals to this. So when you do this and you run it, it would basically create a backup file. So when we run this, it creates a copy of what we have. So we can easily hold this in our data. Also, one of the etiquettes in data analysis is that you should always have backup for your data. So there's this joke in analysis that you have, for instance, somebody says, the database has crashed, and the team lead be like, where is the backup? And the person say, the person, one of the data analysts or data engineer says, guys, our server has crashed. When the person says server literally means your drive, where your data is sitting on. So you'll be like, and everything you have in the data, the database, all of the data you have is sitting on the data, is sitting on the server. Now that the server has crashed, it means you cannot access it. So you need a backup so that you can work with it. So if the team lead asks and says, where is the backup? And you say it is on the server. That means your backup and the data that you've been working with, everything is on the same site where the server has crashed. So basically, that's just telling us that, one, you should always have a backup for all of the data that you are working with. This is something that you should try as much as possible to remember whenever you are working with data. I mean, we like data. If you are playing around with data in terms of sample data, you might not really see the importance. But when you are working with live data, I beg us, always have backup for the data you are working with.
Yes, sir. Hello, sir.
Yeah, I'm with. Yes, sir.
Yes, sir. This sales data backup, is it not a backup on this same server, or is backup somewhere?
So yeah, what I'm saying is, this backup that we have created, this copy file that we've created, is sitting on the same server like our own laptop. But when you are working on real life data, all of your backup should be sitting on another server that you are not working with. So the backup itself should be copy whatever is in this server, put it in another server, and don't touch it. That is the etiquette, so that you do not alter whatever is there, and whenever you need your backup, you can easily go back to what you have. That's why the backup file is there. So
it means that before cleaning the data, we must first create a backup.
yes, before cleaning the data, that is when you should create the backup.
Okay, sir.
Yes.
Okay, sir. Excuse me, sir.
Yeah.
So what you're saying now is that it is advisable that the first thing to do, even before removing, copying, and everything, we have to create a backup first.
Yes.
Before doing any other thing. Maybe you think that the data is too much, you have to remove some things. You have to create the backup first from that the source file.
Once you import the source file to where you are working, the first thing
Yeah.
you should do is create the backup, have a backup.
Oh, okay. Now, my second question is this. Now, you advise that we should not save let the backup be on the same server with the original this thing. So now this thing that you have done now, that like the says data underscore backup that you have done is still on the same server. But how do we put that one that we are doing on another server?
Okay, so in situations like that, what you would have to do is Pandas has a structure called and when you want to bring in data, we use read pd.read, right? So Pandas also has something called the export feature. So when you want to read, you can write. So for instance, we can have pd dot to csv. Oh, sorry. Sales data backup dot to csv, and then I can create a file called sales data backup file .csv. Now, when I run this, right? When I run this, I am going to have it. I'm going to have it created. So when I run this now, you see that it has created, right? Where did it create? It created inside the folder that we had previously. So let me show us. Okay, so now let me stop sharing for a minute, and so let me know when you can see my screen, because I want to show us something here. Can you see my screen?
Yes.
Yes, sir.
Yes.
Okay, so when we run the backup file, you see now that I have this here called sales data backup file.csv, which was created seconds ago, right? So what
Yes.
happened there was that the data that we had inside this backup file here that we created here, this backup has been exported to this location, right? Now let's now do something. Let's now say that I don't want this backup file to be created inside this folder that I have. I want it created inside let's say implement Python folder, right? Inside this implement Python folder that we have. Are we together? Now if you look at
Yeah.
my implement Python folder, there is nothing called sales data backup file, right?
Yes.
Now so let's go to my code here. So I'm going to rewrite this code, and I'm going to say Ctrl V. I'm going to say create backup file in another folder, something like that. Right? Create backup file in another folder. So let me just copy the file path here. Oops. Next. Then, so I have implement Python. think that's the name. So let me just come here. Oops. Oops. Sorry. I want to pick the file path. So I have the file path of where I want my data to go. And I also now want to call my file sales data backup. So I expect that this now goes inside this implement Python folder, and create something called sales data backup. So when I come here now and I scroll down, you see now that I have this file called sales data backup file that was created seconds ago. So this tells us that you can literally, once you import the data on your server, you can export your data to another location from your code. Are we together? So that way, if something happens, so let's say for instance, this is a server. Implement Python is a server. For instance, it is a server, and this Python for data analysis class is also another server. So I am working on Python for data analysis class. This is the server I am working on. I can move my backup file to another server called implement Python server. Are we together? So there is no, how would I call it? There is no static way to say, oh, your backup, you do it like this. You can easily move your backup from where you are working to another server. Even when you are working on different tools, for instance, you are using SQL Server and all of that, you can always move files, you can move databases from one location to another location. Are we together with that?
Yes, thank you.
All right, sir, you're welcome. So let's continue with what we are doing. So we have, so now we've seen that we can, so now we have, so let's just forget that we have a backup somewhere, right? So let's continue our data now. So we have sales data that we are working with. And oh yeah, I think we're talking about removing the other columns that we do not need from our analysis. Yes, so let's continue. So we want to remove the unnecessary columns that we have. So we run this now. We now have, we don't have a phone number anymore. We don't have address line anymore. We don't have last name and first name of contact, but we have our customer name. So our customer name has to be there, but we do not really need their last name, although we can need last name too, depending on the type of data you are working with. So now we have the data that we'll be analyzing. And so the next thing we did was to perform some simple analysis. So now, how do we then perform analysis? Now, so let's start by, oops, sorry. 3, 4. Change this to markdown. So, I hope we are familiar with something called the group by function. So what does the group by function says? The group by function basically is used to group items together. So we know that we have how many number of rows? We have 2,800, I think. Let's check dot what is it? The shape, right? Yes. So we have 2,823 rows of data. Now, these are sales data, for instance, and we want to say, let's say we want to know the number of shipped products, of shipped orders that we have. Are we together? So we want to see how many orders have we shipped. For us to do that, all we need to do is use the group by function. That way, we are able to see the number of orders. And how then do we use the group by function? All we need to do is say sales data, right? And then we call the column that we want to group by on. So I say, for instance, sales data and order dates, right? And I say dot group by. Now, when I run this, it is going to create a group by. Okay, so it says there's an error. So what is the error? It says you have to supply a bicolon. Okay, so let's move our. Oops. So let's go by this. So now it creates a group by function object. Sorry, it creates a group by object for us. Now, how are we now able to visualize what has been grouped by? We need to use one of the aggregate functions. What are aggregate functions? Aggregate functions basically are the functions we use to perform operations like sum, count, average, mean, all of those are aggregate functions. So now here we just say, for instance, count. So what do we want to do? We want to see the count of items based on the group by column called order date. So when we do this and we run it, now it's going to create a count for each of the days that we have. So we have 252 days in the orders, and then we'll see now that there are different columns. It's going to perform all of the activity, all of the operations on all of the columns, right? So we see order number, we see quantity ordered, and all of that. Now, if we now want to say, oh, we want to only see the total number of orders for each days, what we'll do is we'll now call the column that we want. We want to pick order number. Or let's say we want to pick some of the count of sales. So we know the number of sales that we had. So we just put this in quotes and we run it. Now we see each of the days that we have. January 6, 2003, 4 sales were made. January 9, 2003, 4 sales were made. January 10, 2 sales. Now we'll be able to now see that for each days, these are the number of orders that came in. Now, don't forget that if we look at our data very well, we'll see that there is a difference between the order and the order line. So order means that somebody comes, one customer comes and says, I want to buy bag and I want to buy shoe. So the person bought 2 bags and 5 shoes. Now the quantity of the person's order is 7 and the person bought 2 items, 2 different items. So the 2 different items are identified as order lines, and the quantity is on the what is now under what's it called, the quantity ordered. Now we would see something in our approach of analysis. Let's say, for instance, let me remove this again. So we see count here, right? Now let's now run the same code that we have here and perform a different aggregation. So let's now run sum here. Now when we run this, we would see something. We would see that there is a difference in the way the data is visualized. One, when we look at the count, all of the counts have the same numbers for each of the rows. Order number 4, quantity ordered 4, price 4, all of that, the same thing. But when we do sum, what does it do? It adds everything together. So our order number was an integer, so he added all of the other numbers together. Our quantity ordered are numbers, so he added all of the numbers together also. He added all of the price together, added the other lines together, added the sales together. Now, what does this tell us? This tells us that if we can't do a count on our order date, the column that we are grouping, we would have a unique count of what is there. It will count each of the rows. But when you do a sum, it will add everything. Now, you have to be careful with the way we now use aggregation on each of these columns. So if I say I want to know how many orders did we have on a particular day, I will use count. But if I say what is the quantity of the orders that we sell for each day, I will do a sum and I will be using the quantity order column. Are we together? But when I use a count here, I can literally use count on any of the columns because they will give me the same answer. But when I use a sum, I have to be sure that I am doing that sum on the column that I need. So we need to pay attention to the question that we are asking. And that is where analysis requires us to think. We need to be sure that, oh, this column that I am picking is going to give me the exact result. If somebody says, I want to see the daily sales that we have for each day, the daily sales could mean in terms of volume, which means numbers, or in terms of value, which means amount. If it is in terms of volume, it is 4, but in terms of value, it is $12,133.25. So we need to be able to see the difference between the sum and the count. And we should also be able to know when we are using these aggregations. Are we together? So let's now move on. So let's say we want to see the distribution of the days that the distribution of the quantity that we sell or the orders that we have. So let me just say here, let me make it easy. So we say total number of orders per day. Are we there? So now I reduce my order number colon because this is the colon that speaks directly to each of the orders, and it makes sense for me to use the order number colon. So when I do this,
hello sir.
Yes.
Yes, sir. Sorry to bring you back. I think in our first slide, I said something that please, whenever you are doing example for us, use separate line so that this going back to edit. Some of us will go back. Some of us, when as we are here now, we might miss some things. It's not a rocket science that we are not going to miss some things. So in order not for us to be asking a lot of questions, we know that okay, as you are saying it, you are dropping it here. So it will be good for us that you use separate lines for separate examples, so that when we go back, we will save each and every one of us time for you to demonstrate and illustrate everything you want to illustrate. So that, but when we go back to our home, we'll be able to look at it. Okay, this is what you are saying on this line. This is what you are saying on this line. Please, sir.
Okay, got it. Thank you very much for the reminder. So, so we now group by using count here, and we've done the other date. So here now I want to see the total number of orders per day. So now we used the order number column. So we can see for each of the days, we are able to see what we have here. Now, same thing we have for our group by, but now we are using the sum aggregation. So group by order dates. using some function. So let me say using count function here. So now we are able to see the difference. So here now I want to see, okay, what is the amount I make for each of the days, right? So I say total amount, total sales amount. I can also call it total sales value, depending on how we want to put it. So let me just put in column value. So for each day, right? Because we are performing a day analysis from what we are doing now. This is just an analysis on the day. And here we'll be using the sales column because that is the column that speaks to the amount that was made for on each day. So when we look at this, we would see certain things. Now, for instance, if we look at January 6 and January 9, January 6 and January 9 had the same number of orders, right? Four orders. But in fact, on January 6, the value of the amount made was more than the value of the amount made on January 9, even though both of them had four orders. Are we together? Now, one of the things we could also look at is what could have been the reason for that? So if we go in depth, we would see now that there is also a difference in the quantity orders. So if we come here and say we want to see the quantity ordered for each day, this time around, so it is not sales anymore, it is quantity ordered, right? So we can say total quantity ordered for each day. And so here now, the column will be picking from our total sale sum here would be quantity order column. So here we can now understand better, oh, this is why I should pick this column whenever I am performing this analysis, so that we do not mix up the columns to pick. So we see now that we are using the same group by function, but now we are picking a different column in terms of what should it be grouped by on. Now, let's now say that, here I have only sales column. Here I have only quantity column. What if I want to have two columns together? Since we have all of the columns here, right? And I want to say, give me all of the columns, give me X, Y, Z columns from this group by function. How do I do that? So if I want to have multiple columns from a group by function, how do I do that? So let me just copy this. So here I would say quantity ordered and sales. Is that the column name? Yes, sales. So when I run this, what does it say? It says there's an error. Why is there an error? So the reason why there is an error is because I did not call my quantity order and sales column correctly. How am I supposed to call them? I'm supposed to have a double quote because this is a multi-dimension. It is not, this is coming in form of a series. Are we together? This is coming in form of a series. Now, because we are having multiple series, we will now have them as a data frame. And now we see that when we include our square bracket twice, it corrects the error that we have. I deliberately do this because so that if we see the errors while we are in class, we are able to remember, oh, this happened when we were doing this, and then we are able to correct it. So now from this, we can see now that we can have multiple columns from the same group by function, right? So how then are we going to be able to perform certain operations? So let's say I need to know the number of orders for each day and the total amount for that same day. Situations like that you have a different aggregation on the column that you want to go by on, you will not be able to do that unless you create the different tables first. I mean the different series and the two different series, and then join them together later on. And that's a different ballgame entirely. But here now we are able to see that we have quantity ordered and sales. So now the next thing we want to do is we've been able to see for each of these days, but we are not able to know, oh, which one is the highest, which one is the lowest, right? So how do we then know which is the highest, which is the lowest? How do we know which day is the least what's it called, is the least sales day, and which one is the highest sales day? For us to do that, we would use one function called the count function, the value count function, I mean. So how does that work? Oh, sorry, did I just say value count? That's a wrong thing to do. There's something called the sort function, because what we want to do is we want to sort our data, the data that we have, we want to sort them in either ascending order or descending order, depending on how we want to work with. So here I want to say sort the total number of sales. So sort total number of sales per day in, let's say, descending order of sales, descending order. Yeah. So this means that from the highest to the lowest, we want to sort. So how do we do that? So we have a function called the sort function. So when we do sort underscore values, what happened? Sort underscore values, inside it we then have this. So if I run sort underscore values, it sorts in ascending order. You see we have 1 1 1 1, and this is not what we want. So what we want is in descending order. How then do we do descending? So we come inside this our function, because by default it is in ascending, so we say ascending equals to false. So when we run this now, it goes in descending order. Now we are able to see the day that had the highest number of orders. Same thing, so it goes 38, 35. So we are able to see the days that have this. Now let's now say I want to pick the top 5 best-selling days. What I would do is I would say, let me just say top 5 best total number of sales in descending order. So I have this, and I'll just say dot head. Don't forget, our head function gives us the first 5 whenever of the data that we have. So we just put this and we put 5 inside. So this will return the top 5 days for us. Same thing if we have it in descending order. We want to see the least 5 best-selling days, we'll be able to do that. Now, same thing we can do with our multiple column here. And this would be something I want us to pay attention to. The reason why we are doing all of this before we begin to plot is so that we are able to see better how we perform analysis first before we then plot. So now, if I want to pick, if I want to sort all of this in ascending order, so sort sales and quantity order. Total sales and order quantity. in descending order. Same thing I would use dot sort value, and once I use this dot sort values, the next thing I'll be doing is I need to state, okay, before we even state, we should be able to, what happened? So here, when I run this now, it gives me an error. Why is it that here, when I run this dot sort values, it gives me an error? Meanwhile, when I ran it with this one column data, it did not give me error. The reason why it gives me error here is because here now we have more than one columns, and it needs to understand which of the columns do you want me to sort by. I have two columns. I don't know which one to sort by. So that is what is happening here. Meanwhile, in the first one that we had just one column, it saw that, oh, there's just one column. So automatically, that's what I'm supposed to sort by. So now here, we have to say by, so let's say we want to sort by sales. So we say by sales. And we want to sort in descending order. So we say ascending equals false. Are we together? So when we run this now, we now see now that we have a sorted order in the order of sales. If we want to be sure that, oh, what we've done is correct, if you look at November 6, the quantity order is 977, which is lesser than 1093. But because the total sales was more than that of November 12, it automatically puts it ahead of it. So this is the difference in the sorting, and the reason why this is how the sorting system works when you are sorting by a particular column. Hope we are able to understand this. Now, let's now visualize what we've been doing so far in terms of let's visualize what we've done so far. So in terms of grouping by a particular column, which is we are working with the order date. Now let's start from the first one that we have. First, we created a count of each of the orders that we have, meaning the total number of orders per day, right? This was the first thing that we had. So let's visualize what we have. Now, don't forget, and don't let us mix up something. When we did this, we had our date column ordered, right? Compared to when we now sorted. So when we grouped by our date column, it was ordered. So we see it goes in a normal date format of day 6 before day 9 and all of that. So now let's run this here first and see that we have exact data that we want to visualize. So this is the data we want to visualize, right? Now, let's now visualize using Pandas. So we say plot a bar chart for total number of orders per day using Pandas. We want to use Pandas plot function. Pandas has a function called plot. How does it work? All we just have to do is we say dot plot, and then inside dot plot we would now say kind. So kind means what kind of chart do we want to plot? So we would say bar. Are we following? We'll say bar. Now, so let's run this now. So when we run this, this is going to plot a bar chart for us using the data that we had for what's it called? For the order dates in terms of the number of orders we have per day. So when we do this, we see here that our data is so dirty. Like we are not able to see which day is which day, right? and this is a problem. So this is one of the limitations of plotting with bar charts, right? So how are we able to fix this, and what do we need to do? So what we need to do here is where other what's it called, um, other libraries come into play. Now, how are we now being able to use the other libraries? So first is we see here that we have the order date, right? So the order date is where the date column sits and the number of orders. So let me a semicolon here. So yeah, I need to show us something also. Also, we see here that there is this axis subplot x label order date, right? If we don't want this type of information to come up on our chart, we use this semicolon to remove it. So when I put semicolon, it's going to remove it. Another way to remove it is also using something called plt.show, which is basically PLT. If you remember, our PLT is coming from our Matplotlib, right? Don't let us forget. So if we do this, it is going to remove this, but I'll show us how that works later on. So let's now use let's now plot bar charts on the same data that we are working with, but this time around we want to make our we want to use Matplotlib function, Matplotlib, and Pandas plot. So here now we want to use both Matplotlib and Pandas plot function together. Now, the first thing we are going to do is, one of the reasons why we cannot see our chart very well here is because it is small, right? And we cannot create a what's it called, a size function in Pandas plots. We cannot say, oh, give me this size. We can't say that. So for us to do that, we would use something called plt.figure. Now, plt.figure, what it does basically is it helps us, let me say, it makes plotting much more easier, right? So we create a figure function, and inside it, we now say, we now give the size of what we want. So for me, I'm going to say I want a size of 20 by 10. 20, which is the sorry, here I have this. So 20, which is the breadth, like the width of my chart, and 10 to be the height. So let me show us what this is going to do. When I run this, this creates a okay. So this creates a figure function for us. Now it says it has 0 axis and on both sides. So now I've created a function, a figure here. So we see that the figure has created. Now, how am I then able to use my figure with the Pandas function? Now, what I'm going to do now is I would copy my plot function that I have here, and I am going to paste it here. So the PLT figure that I've created here is creating a chart size, right, of 20 px in width and 10 px in height. So now I'm going to plot this. So when I run this, this is going to take a while, and as you see, it has created the stop plot the way we had it previously, and it's going to take a while to load, and now we have our order date. Now we see that our chart now is bigger than what we had previously, right? So we see that our chart is now bigger, but our order date is dirty. How then do we fix things like this? Now, the reason why this is coming up is because there are a lot of different order dates, and it could not really separate them. And this is one of the limitations of what's it called, of working with plenty data in this form. So for us to fix this, we would then use the Plotly express function. Now, the Plotly express function works by us creating a a data frame itself, sorry, by us pushing this how would I call it, this group by function that we had, like the analysis we've done, inside the px function. So how does that work? So let's come here and say we are creating a bar chart now of the same, using the Plotly, using Plotly express. Let's just put Plotly. So here I would say px, because we've created px, right? And then we can see we have different form of charts that we can have inside px. Now, if you look at all of these are all different chart visualizations that we can have. So we wanted to create a bar, right? So we say px.bar, and then we pass in our analysis, what we want to visualize. Oops, what have I done? And then we put it inside this, and then we run it.
Sir.
Yes.
I want to ask, what do you press to bring out all the different bar charts, different charts? What do you press?
So when you press px, you
Okay.
press dots and you press tab, the tab on your laptop, on your keyboard. It's going to take some minutes. You can see here it is dark while it is loading, and so when that does, when that completely loads, it will show all of the charts that are underneath it. Now we see here that our plots is taking some time, and you see it has given me some future warning things because of certain things I'm working with. Now it said something about our date time, which is going to be a challenge, and would also be working with here. So so we see it has created a visualization for us, right? And so if I scroll up a bit, here you see in my visualization, this just shows me lines. It shows me different lines, but nothing is understood here if I really don't know what's going on, right? But if you look at what PX has done here, what Plotly has done here, Plotly creates the lines for us. One, it also visualizes in terms of our months. So it automatically picks, April 2003, July, August, compared to what Plotly and Matplotlib could have done here. Now, what it then does for us is we can see here that when I come on a line, it tells me what is in that line, even though the line is small. And I can also zoom in. So if I highlight this, I can zoom in, so I can say I want to visualize April, and then I'm able to see January 26th, January 31st, February. So I can zoom in, and I can also zoom out. So if I go back to zoom out, I can go back to auto scale. So you see that I can easily zoom in and out using Plotly. So this is an interactivity feature that Plotly has compared to other plotting libraries that we've seen so far. So this is one of the ways to use all of this. Now, also, before I go on, let me even show us some other ways to plot, because what I've done so far is not the only way to plot. That's one of the things that we should note. So, for instance, let me insert a cell below. Now, remember that we created PLT the other time as Plotly, right? So when I run this tab, you can see I can create a lot of things with PLT, right? And inside PLT, I can also create a bar function here. So if I do PLT.bar and I have this same thing here inside my PLT.bar, same way I ran this code is here. So it says it needs to define height. So let me say height. Okay, let me make it easy for it. I'm going to use the same PLT size figure that I've created previously, so that I don't have to run all of this thing again. It says height is missing. Yeah, you don't need height, Gary. So we see now it says bar container object. So it creates bar container object for 252 items, compared to what Plotly says here. I say Plotly. Pandas plot says here, axis subplots, X bar, and all of that. So this also takes time to load, and we are able to see how we plot them. Now we see here that it just automatically gives everything the same number, and this is wrong. So we should not do something like this when we are plotting. So I basically just called our attention to it, because whenever we are playing with the Matplotlib functionality, we are able to see, oh, this is what we can do. Let me play around with it and all of that. So we should not do this. So I'm going to clear this. Now, I also want to, I think another thing we should also see is how Seaborn handles plotting. So we created Seaborn functionality the other time when we created import Seaborn as SNS. Now, how does Seaborn handles plotting? That's another thing we want to see. So we do SNS dot and we do a plot. We see we have a bar plot, and when we run this, we can see what are the things we need to import. All you just need to do is put in your data, mention your x-axis and your y-axis. Are we together? So you see here we have, so let me go to example so we are able to understand better. So it says SNS Seaborn. So you say your x and your y-axis, right? And then the data you are working with. So it means that for you to use SNS, you would be working with the whole data. So our data is sales data, and our x-axis, our x is order date, right? Order date, and our y-axis is order number. Our y equals order number. So when we run this, this is going to take some time, and it's going to also, so we see how each of these libraries handle plotting. And so I forgot to add, okay, so now we see that our order has been created, and it created like a pattern, like there's a growth pattern somehow, and gives color and everything to it. But this also does not look like a good thing to visualize with. So in everything we've seen so far, we see how the data has been handled in terms of the data we are working with has been visualized by the different libraries that we have. And it has not given us something quite interesting or something good, except for Plotly Express. Now, one of the reasons is because the data that we are working with is much. We have 252 order dates each of the days. That's a lot. So we see that it is a problem for these libraries to handle a lot of dates, or a lot of, what's it called, a lot of rows of data. That's because the column we are working with is a daily order date, right? So let's now go back to our data and do some manipulation. What is the manipulation we want to do? We want to create, we don't even have to go back to our data. Our data has a month column, right? Our data has a month column. And we need to do a manipulation. As a month column and also a year column. Where is the year? Go back. It has a month column and a year column, right? Month ID and year ID. Now, what if we group by these two and we perform all of the things we want to do, right? We should be able to group by 2 columns and perform our analysis. So we are able to see in February 2003, this is the total number of orders that we have. In June 2003, this is the total number, right? We should be able to do that. Now, I'm going to show us 2 ways. First is the data that we are working with, God so bless us, already has a month and year column with it. But what if it does not have in the first place, and we have to create a month and year column into it? How do we do something like that? For us to do that, all we need to do is we need to go back to our dates column and restructure what we have. Are we together? So we'll be creating a new column called month year column. So we're creating a new column called month year column. And inside our month year, all we just want to do is it should join our order dates, right? It should join them together. So I would like to do this before our analysis. I would like to do this before our analysis so that we understand. So now we want to create a month year column from our order date column so that we undo all of this. So to do that, we would say sales data, open brackets, order date. Open bracket, order date, right? And then we now say dot. We open our dot and then we try to see what we can do on it. Now we see something called .dt. Now what does .dt mean? This is .dt. .dt is basically a date time function, because the column we are working with is a date time function. Don't forget, we've changed our order date to a date time, right? So now we have a date time function that we can now use to pick a period from. So we want to change this to, no, it's supposed to be to period. So we want to pick a period, and the period we want to work with is our month. So when we do this, we'll see now that it gives us the month and year of each of the dates. Month, year, month, year, month, year. We see it, which is almost a concatenation of what we have here. Month, year, month, year, month, year. So we have it here now. Now we are going to create a new column, and we'll call the column So we say sales data, and we'll call the column months underscore year, so that this column is created. And we say sales data dot head, so that we are able to see what we have. So when we run this, it creates the column for us, and then when we come here, we see month year column, right? So we automatically now have a month year column, which holds a combination of these two. Now, this is one way for us to create a month year column. Another way is for us to join or concatenate what we have here. So I'm just going to show us how to write the code, but we will not be using it. So we'd say pd dot, if we see pd dot and we come down, we see concatenation as one of the functionalities we can do. So concatenation, now what do we want to concatenate? If we go inside, we see it tells us objects, either iterable, it's a series, a data frame, anything you want to concatenate together. And how does it work? You basically join two columns together. So we say join A, comma B, all of those things together inside one column. And whenever you concatenate, you can join them together. So I want to have sales data, and I want to have, sorry, so I want to have the month here, and this is going to be, oh, sorry, this is not even what I'm supposed to do. What I'm supposed to do is not even concatenate. What I just have to do is print this, comma, put this in quotes, dash, and this. So, no, what's going on? What's going on? This does not undo what I want. Oh, what am I doing? Sorry. I'm doing nonsense. So the second thing, way to handle that was for us to use a group by function on two columns together. That was what I was supposed to do. So it was supposed to be sales data dot group by, and I'm going to group by two columns. So the two columns I'll be grouping by are month ID. I'll be grouping by month ID and year ID. So when I do this and I run this, so I want to do sum, for instance. So now it gives me an error and it says, what's the error message? Date time does not support a sum function. So that's because we have a sum function in one of our columns. So let's do a count. So now we see, so now we see that we have two what's it called, group by functions in terms of how it handles month and year. So we have January 2003, January 2004, January 2005. Now if we look at this orders each of the months in the hierarchy of how we state it. So for instance, if I state year order first, so let me come back here. So let me create a new cell, insert cell below, and I come here and say group by year ID first, comma, month ID, and I run this. We would see that it does 2003, January, February 1st, all to December 2004. So we are able to see the difference in which how this handles each of them. Am I even supposed to have this here? So just put group by months and year ID. Now sincerity, this shouldn't be it. Okay, so I want to do something, please. Sorry. Okay. So what we had, what I ran the other time, we should have it here, so that we are able to follow some things clearly. So if we do this, we go by our month and year, we see how this works first. And when we do this, we see how it handles this. Now, when we have this, let's now see how, when we group by the month year column that we have, like the one we created above, let's see how it is going to handle the group by. So now we have group by month year column, so that with this we are able to see the certain differences that comes with handling group by, and also how Python handles them. So when we run this, now we see that here we do not have multiple columns in terms of our group by, but here we have just one, and everything flows accordingly. 2023-01, 2023-02, and it goes like that up until to the end, compared to this one that creates a difference in terms of breakdown. So with this, we are able to see how handling a group by function with multiple columns is done or is handled by Python, and how when we create a group by a new column from our date function, sorry, from our date column, which is the month here, we are able to see how each of the data or each of the rows is handled. And the thing is, when we look at the month here that we have here, and the data that we also have here, they are literally the same thing in their flow, literally in terms of how the numbers are, but in their visualization, they would not be the same thing if we look at it. So let's say we want to work with this group by, and let's work with the other number. So let's have so that we are able to see clearly how Python handles all of this. So let's take the order number column from here, and so let's say plot a bar chart on year ID, month ID for orders, for total orders here. So when we do this now, and we do this, so we are able to see each of the what's it called, each of the rows now, 2023, January, February. So when we plot this, 1 minute, 1 minute, 1 minute. Yeah, I'm with you. Yeah, I can hear you. I'm with you.
I think you want to show us something on concatenate. Is not a function we should use, because I think you mentioned something like that before and you not concluded.
Yes. Okay. Yeah, I'm going to still talk about concatenation. You know, I also talked about it when I mentioned joining two data sets from your group by. So let's say you've grouped by what's it called? You've grouped by date and you have a count function, and you have grouped by date and you have a sum function. How you can join them together. I'm going to also talk about that also when we get to after we've done this. That would be the next thing I'll talk about, because there we'll be visualizing multiple colons at the same time. Yeah, thank you for mentioning it. So now,
sorry.
we
One more thing.
okay.
You said I think when you were trying to do it, it did not concatenate because it said because we have the sum function somewhere. I think you understand what I'm saying.
So the sum function was on the group by that we created the other time. So it was a different code for. So we had two codes. We had one running on the count aggregation function, and we also had one on the sum aggregation function. So I said that the results that we had, they all had this, they were grouped by the same colon, but we could not do that. We could not extract such detail from the same group by function. So for us to have that, we would have to concatenate two different results inside one, so that we are able to do it, so that we're able to visualize it at once. Yeah, I'm going to still get there and talk about it.
Okay, all right.
So now, here we see that we have our year colon, the month ID colon, and the total orders for each of the months. So here now, if we do kind equals to bar, sorry, I need to, I just want to copy what I created the other time. Yeah. Okay, and so edit. I want to. Okay, so insert will. Yes, thank you. So I need to, before I do this, so before I plot the bar chart, I want to make sure that I have, okay, so this is what we have before plotting, right? So when we now run this to plot, it says bar not, okay, sorry, it's supposed to be in quotes. So when I run this now, so here now, we now see that, okay, I was supposed to have using Pandas plots. So now here we see that I now have a much more cleaner visualization, although it is small, but it is cleaner in terms of what we can see. And we are able to see that, oh, this is January 2003, February 2003, March, all the way to December. And then it goes again, same structure and all of that. So this is how we visualize our bar charts now using month and year. Now you see that here we have the year and the month separated by commas, right? Because we have multiple columns that we've grouped by on. That is why we have that. Now, if you look at the same thing for our month year column that we've created, so let's also use. Okay, let's also use this. So come here and say data number of orders. So also here I can remove my square bracket, I can leave it. Anyone will do is fine. So by, okay, so you have total number of orders by month here. So when we run this now, we see here that we have just one single column handling all of this. So now if we come here and plot this, so we say plot using Pandas plot function. And so we come here and say that plots, and we say bar. Oops, it says blah 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 blah. Okay, sorry, my bar is my problem. What's happening? Series should not be. Oh, sorry. Kind. So I was supposed to write kind equals bar. Yeah, kind equals bar. So we can see now that here we have exact structure of how the column is 2003-01, which is the same format that it is here, 2003-01-02, which is what we now have here. And if you also look at here in our bar, it says in the column here, in the x-axis here, it says year ID, comma, month ID. But in our column here, it says month underscore here. So this way we are able to see the different visualization. So now let's now continue with the structure that we have. So I would be using this our month here. I won't be using this year ID, month ID anymore, based on what we've created previously. So let's now use our, what's it called? Our Plotly. Sorry, I said Plotly. Our Matplotlib and Pandas function. And I'll be using the same figure space. I said figure space, figure size. And all I will be changing is the data I am plotting. So here we have month here. Also, I do not want this axis plots and all of that to show anymore. So I'll be using my semicolon. I also told us that we can use plot plt.show, and it would remove it. So any of them that we use is fine. So we see here now that this visualizes what we want in so much cleaner way, and it is much more better now than what we previously have here.
Hello, sir.
Yes, sir.
Hello, sir.
Sir. Yes.
Let's assume we want to extract a day of the week. Is it possible? So that we visualize through day of the week. Like month,
Okay.
Thursday, Friday, Saturday.
Okay, so if we were to have day of the week, so what we would do is we would have to do that from our data or our dates, other dates also, where we created, where we had sales data, open brackets, other dates, dots, and DT. So, sorry, dot DT, and then from dot DT we can then create. I think it should be name. 1 minute, let me confirm something. Extract yeah, dot dt, and then we would return day name. So all we just have to do is dot dt, and would use dot day name. So when we do this, we see now that we have Monday, Tuesday, Wednesday, all of those days. So by this, we'll just create. So let's create our sales data. Oh, okay, sales data, and say day of week, and then I say equals to this, and I just say sales data dot add. So when I do this and I run it, you can see that I have February 24, 2003. So when I come here, I see, oh, February 24 is a Monday. Are we together? So when I do something like this, I can then proceed to say, okay, group by. So I can do something like this, where I say group by day of week, day of week, and then when I do this and I run it, I'm able to have Friday, Monday, Saturday, Sunday, all of this, and so we are able to see which day of the week has the highest number of orders in total, or which day of the week is always the busiest. So see, we can also even do this in terms of ascending order. So we can say sort values, um, sort values before it plots. So we see, oh, our Sunday is the least busy day. On Fridays, we have a lot of orders. So we can see, we can even sort in descending also, from what we've done previously, where we say ascending equals to false. And when we do this, we see the most busy days in terms of orders. Hope we get this, right? Are you able to get
It's
what
clear
we've done?
now.
So, okay,
It's clear.
all right. So Python has a lot of functions. Even sometimes, let me also tell us, even sometimes when we run certain functionalities, there are some that we do not see even in our Python, that we might even need to go online and check. So if we do .dt here, we see all of the extensions that we have. We see that we do not have date name on it. So we need to check all of those things. So we can go and say, sorry, if I do name here, and I run this, so it says, oh, the string is not callable. Order, okay, it's just the name. So if I do day, it says series is not callable. So you see, it gives us the day if we have all of these. So these are some of the functionalities that we can see from Python itself and we can use. So let's go back to what we're going to explain. So here we've done how we can use what's it called, Matplotlib and Pandas to visualize. Now let's now visualize this same data using Plotly Express. Same way we did it the other time. We say px dot the bar type we want to use. I want to use line. Yes, I want to use line charts so that we are also able to see it very well in terms of the month. So I'm going to remove my plot here because I don't need this. So here I want to plot a line chart for total orders, total monthly orders, because this is going to be in terms of months, orders, right? Using Plotly, So now when I run this, it's going to take a while. Okay, it says there's an error. What is the error that we have? Oops, it's a long one. So it says it's supposed to have. What happened here? I don't get what is going on. Can I do something wrong? Okay, so our px.line is giving me an error. Why is it giving me error? 1 minute. Something is wrong somewhere. Let's go back to what we had in our px and see. Yeah, it's not supposed to be this stressful. What is going on? Okay, let's figure out what is going on. It says there's an error in the yes. This is long. I do not care what you want me to do. says I'm supposed to have a figure. Object of period is not JSON. I didn't import a JSON file. Are you kidding me? What's happening here? So, okay, let's start from the beginning. Oops, sorry about that. Okay, let's do something. First, we have this. Yes. So now we want to visualize this. We say px dot, we have bar, and then we visualize this. So why are you giving me an error? There is a problem somewhere. So let me go back and say other dates and see. This works. What's the problem? Month here, and you're telling me JSON. Something is wrong. Why is this thing stressing my life? Saying object of period is not JSON. Okay. Oh. What happened was that, so let's go back to something. Let me show something. So the reason why it's mentioning JSON is because I extracted month here from my data, but that's not supposed to give me a problem because it's supposed to work. It's supposed to work regardless. It's supposed to work. Why is this thing stressing my life? So let's go back to something. Sales data. So let's see something. We have sales data. The info. So tell me about this. So I have a month year colon. Our month year colon is period of month. The data type is period. So what happens is my how do I call this guy? My Plotly is seeing this period as a problem and is seeing it as a JSON file. It's seeing it as a JSON data, which is not JSON data. So how do I solve this problem? And I have to check. So let me check.
Hello, sir.
Yes.
Hello, sir. Maybe we should start a day of the month so that we can see it January, February. The line chart should be in January, February, or something like that. I don't know if I'm wrong.
Okay, so we want to see which month is the busiest.
Yes.
Same way we had day of the week, right?
The trend per month.
Yeah, okay. Yeah, that's exactly what I wanted to do with PX. Because if we see Plotly Express as a functionality where it automatically creates the month's name for us from the other dates that we have. Are we together?
Yes,
And so we are able to see which month is how do I call it, is the busiest and all of that, like a line trend. That's exactly what I wanted to create using our px function here. When I said px.line, when I said px.line here the other time, and it gave me the error. So we can do that. What you've mentioned, we can do that with our plot here. So let's say, so I'll come back. Oops. I'll come back to this guy that is giving me error here. Let me just fix this guy. So I'm going to come back here. So here now I can just say line. So when I say line here and I run it, it's going to create a line chart for us so we can see a trend. And we can see it is coming from January. Don't forget that our data itself is in terms of numbers 2003, 01, and all. But the charts automatically identifies what we are doing, and so it creates a line, and it renames each of the months for us. So we see January 2003. There's a flow. and the peak months, and then it comes again. So if you look at it, there's somewhat like a structure in terms of the peak months, the month in which the sales goes up, and then it drops again, and then it goes again, and all of that. So we can see a line chart here. So this is a line chart. Does this answer your question?
Yes, sir.
All right, sir. Okay, so yes, so now back to why our PX is not giving me what I actually wanted. So it was seeing the data that we have as a what's it called? As a JSON file, when in fact it can only handle a data frame. So for us to do that, I need to change my JSON format that I was having to a data frame. Are we together? To a data frame, and for it to do that, God. So this thing is a problem. I have to. So for me to do for import JSON. So when I import JSON, I'm now going to say JSON.dump. So I'll say JSON. So JSON has something called dump. Now, what does dump do? Dump basically formats the file that we have. So it's going to format it, right? Now, this is what dump does. It formats the file that we have so far. So now, what do I want to dump? I want to dump this guy. This is what I want to dump, right? So I say this. When I run it, it says the missing parameter. What is the missing parameter? I mentioned this. So what is the missing parameter? Object. This is the object I want to do now. I'm stressing my life, this guy. Okay, let me make it easy for this guy. It says dump missing parameter FP. What exactly is FP? Oh, this thing is giving me a problem. So let's keep this because this is a JSON error and it's going to take time for us to fix this. So I don't want it to delay us. But basically, for us to fix it, I have to like go through fixing JSON and all of this. But anyways, we've been able to see how Plotly and Matplotlib handles our visualization for the month here. Now let's now go to how Seaborn would visualize what we have. So I'll just copy again. Let's copy this. I'm going to copy this. Oops, sorry. I'll copy this and I would paste here. And my x-axis would now be what's it called? My x-axis would now be month here. So when I do this and I run and do this, sometimes and then yes, so it gives us like a flow also, but this also does not visualize what we actually want very well because this is not correct. And if we look at the way the months here are how that called visualized, it doesn't give us the exact flow of what we actually have. So we'll see here now that Seaborn in itself does not really do what we need per se compared to every other visualization that we actually want. Also, we can do a line chart. So if we run this again, and okay, so there's an error. It says it's the problem. X is null, Y is null. Okay. Oops. One code. All right, so far we've been able to see how we can plot each of the data that we have using wait, pardon. Sorry, please 1 minute. I think I can do something to this. I can fix this PX issue. Sales data. I think there should be another way to do this. Dot month here. So we have this, the data type is period, and I just come here and say as type, and I say date time. I do this, what's the error? It says date time is not understood. So let me do something here and say sales data dot info again. Copy this data and change this to this. So what does it say? It changes this and handle this. Yeah, this should work now. Yes, it should. Okay, so I've been able to, okay, and I should have this as in place, no? Okay. But there is a challenge. So I tried something. What I tried was I tried making my month here to come in form of date time, but it automatically added O1 to all of my data. And this would actually work when we try to group by, but it would only show the first date of what we have. So for instance, if I change all of this, if I change all of this to, so let me bring my code and explain what we have. So if I visualize this using this group by function that I have here, so I'm going to put this inside this. So we have O1, O1, O1 compared to what we previously had when we have, sorry, let me show us again so that we are able to understand the flow very well. Oops, sorry, Control V. So if we look at what we have here, we have each of the months, 2003 January, 2003 February. But if you look at what happens here, it had a whole one to date to all of them because it is now a date time. So if we should do this and visualize this, it would work, but in fact, it wouldn't give us what we were supposed to have. So we can see you have January 1. It's going to make everything January 1, and making everything January 1 does not pass the actual information, because this way you would, if anyone is seeing your visualization, the person would think that you have a data that is reflecting that all of the sales happen on January 1 only, and that is a false interpretation. Are we together? That is a false interpretation, and as such, we should be able to take note of all of these differences that we could have from our data. So these are some of the things that we need to take note of when we visualize data itself. So I want to pass this as my visualization. So these are some of the things we need to take note of when we run analysis like this. So if I try to do this on px.bar and visualize, run this, it works. It works, and then this easily solves the problem. But when you do it on what's it called, on Plotly only, there's going to be a problem. So these are the things that we need to take note of when we are analyzing our data, especially when we are handling a different data type.
Hello, sir.
Yes, I'm assuming.
Yes, sir. In data type, which
Yes.
column are categorized or classified as subject? I still don't understand which column or can be categorized as objects, and why are they categorized as subjects?
Okay. So an object data type in Python includes how would I call it? So what Python does basically is it interprets what we have as what we have when the data that is inside that column is not seen as a number or is not seen as a string per se. So it renames it to be an object. So it sees it as an object. So it sees that there's something here, but I can only call it or categorize it as an object. But I don't know if it falls under a string or a number or a date time. All I just know is that this number or what I have inside this column has different what's it called? Different types of data inside it. So if we go back to what we had previously when we brought in our data, what Python was seeing here is that, oh, there is a number here, there is a string here. Don't forget that we said string is a combination of any character, number, letter, alphabet, anything. They are all strings. But it could not call this a string because it cannot categorically say that what I have here is a string. That's why when you run every other data time, you see even under status, it calls it object because it handles everything all together as one. Do we get that now?
It's clear, sir.
Okay, sir. All right. So um, Okay, so far we've been able to show ourselves how we can perform bar charts and line charts using Matplotlib, using Plotly, using Pandas, and how Seaborn does its own visualization. So we'll go for break now. By 1:45, we'll come back and we would now see other charts and plots that we can also perform using these different libraries that we've seen so far. So that sorry, 1 minute. So that we are able to understand the other visualizations that we can create, the other charts that we can create using all of these libraries, and how we are able to do this from the analysis that we perform. So we've done so far, seen what's it called, how we are able to see the total amount or total number of orders or sales that is done per day or per month, depending on how we want to visualize the data that we have. So we'll go for break now. Once we are back, we'll explore the other types of visualizations that we can have. Do we have any question? Then we can go for break. Any question?
rẹ̀ pé kọ́ ó sì ti fọwọ́ rẹ̀ sáré oyin ó di dandan kí oyin wá ta.
Yeah. Okay, I hope everyone is back. But please give me some few minutes. I'll join us very soon. Yeah. Welcome back. So, okay. I think we are all back, right? Can we hear me?
Yes, we can hear you, sir.
Okay, all right. Yes. So, we've been able to so far see how we can visualize each of the charts that we have. Um, how we can, okay, yeah, I've not even talked about adding labels and colors. Okay, we'll talk about it, and also we'll then look at the other visualizations that we have, and lastly we'll also look at how we can save all of the charts and the visualizations that we've created, how we can save them on our computer. So let me just start with the last one I mentioned, how we can save our charts. So with Plotly has this feature where you can download a visualization. So you see it says download plot as PNG. So when you click on it, it's going to download. But before we do that, we need to do some little changes, which are how we can add labels and titles to our charts so that we would be able to download and see what we've downloaded very well. So I'm going to have to start from the beginning of the chart that we've done so far so that we will be able to see that better. So I'll be doing some little changes to the charts that we will be downloading. So the ones we won't be downloading, I'll just leave them. Okay, so let's start from here. So we have labels, right? We have labels, and what does label do as one of the attributes of sorry. Let me just let me do it the ones that we have that are so clean. Okay, yeah, so let me start from here. Yeah, so for us to add labels to our chart, we need to use for Matplotlib, we need to use the Matplotlib feature that is called the X label and the Y label. So Matplotlib has this feature called labels and title. So for us to do that, we would include dips. So let me just call these labels. I would say PLT dot. So when I look at PLT, I have a lot of extensions, and one of the extensions I have is called the X label. So the X label means that it is going to change, have that label, whatever I put in the X label there, as what would be on the X axis. Now, if I don't want to put anything on my X axis, I could just literally leave it, or I could put X label and put an empty space. So when I run this, I would see now that what I previously had, that had other dates, and on it would not have anything there. So because I had cleared it out. So but if I want to have something, I could say so this is month, so I could say order month. And same thing I could do for the Y axis. So I say plt dot y label, and I say total order. Are we together? Then I want to have a title for my visualization. So I say plt dot title, and I want to call my visualization monthly. Sorry, in quotes. Don't forget to put it in quotes. Monthly orders. So let me call it monthly orders. So this is what I have, and then I run this cell, and after running it, we now see that we have orders, monthly orders as the title. We have total order on the y axis, and we have all month order month as the x-axis. So this is how we add labels and title to our chart. Now, once we are done with this, we can then proceed to download the picture that we have. Here we can just right click and say open image in a new tab. You see that we have our image open in a new tab. And then we can then right click and say save image as. So as this, I will be downloading, and I want to save this inside my desktop under my Python for visualization. So I want to have a new folder. Okay, so let's call this monthly orders underscore visualization.
We can't see what you are doing, sir.
Oh,
hello, sir.
Okay. Let me.
Now from where you right click, so we can't see it.
Okay. So
I thought it was only me.
So let me. There was a problem. Let me know when you can see my screen now. Can you see my screen now?
Yes.
Yes,
okay.
We can see it.
Okay. Yeah. So I right clicked and I said I want to see my image in a new tab. So it opens the image in a new tab for me. So I have this visualization.
Please, where did you right click? Is it on the image or the
on the image?
Okay.
On the image. So I right click on the image and I say open image in new tab. So when I do this, it automatically just opens the image on a new tab on my system. And we can now see the beautiful visualization we've done. And we have all of it now showing clearly. Now here I can save my image as a picture, and I want to save it inside my desktop, inside our Python for data analysis. Then I just call this monthly orders underscore this. So I can save this on my system, and when I come to my folder, I have this visualization here. So I can save this, and I can share with somebody. I can send it to anyone I want to send it to, and the person can easily open the file on their system without any problem. So this is loading. It's going to take some time. Okay, so when that is loading, we can continue our whole task. So also we can add labels to this by basically doing plt dot xlabel, and we say on our x-axis we want to say day of the week. and on our y label, so we have the y label, and on our y label we want to have total orders. So we can decide to also put a title. So we say plt.title, and we say weekly order, or let's say, yeah, weekly order chart. So we are able to, so when we run this now, we can see that our visualization now has all of this. Now we see we have something called text 02, 05, 10, and all of that. We can remove all of the things by just saying plt.show. And then when we do this, we see that all of that is cleared out, and we have this. Yes, one of the things also that we want to talk about is color. So let's say, for instance, that we want to add color to our label. All we just have to do is say color, and we can give it a color code, red, or let's say green. So when we run this now, it says color is not correct. Why? So let's go to our pandas and see what is wrong in what I have done. So I'm going to the user guide, and I'm going to charts, visualizations, and here I see color. So basic plots. Something is wrong. But what is wrong? So let's go through it and see other plots. Pandas, plots, color.
If you scroll back up, I think I saw something like color when you are scrolling down.
Okay. Yeah, I think it brought me back to this place. Okay. Yes. This is supposed to be it. Color equals gray.
Yeah, the quote you use is apostrophe.
Oh, I've seen the problem. I did the right thing actually, but I did not put a comma. So I did not separate it with a comma. I was supposed to separate with a comma. So yeah, also I'm wondering, what did I do different? Okay, so here I have, now we see that the color has changed. Also I can,
I'm going on. So it doesn't matter the type of quote that we use.
yes, it doesn't matter the type of code that we use, correct?
So for that bar, I can use those apostrophe quotes.
Single quotes, yes, you can also use single quotes for the bar.
Single quotes.
Yes, to work down.
Okay, thank you.
All right, you're welcome. So okay, yeah. So for the color, we can write the color we want. So we can say pink. and we see the color, right? We can say cyan, we see the color. We can say which other color? Um, we can literally say it's the color, but I also want to show us that instead of writing the full name of the color, we can write the short form of the color. So that I say color P, it returns, I think, purple. I think so. Oh, something is wrong. What did you say? Color P invalid. Okay. So, but if I come here and say purple, it's going to give me color purple. So I can say, if I say blue, I think he understands blue as B. Yes. So if I say G or R, he understands the color as red. So we can state any color that we want for our chart, depending on the flow we want. So for instance, if I have a line chart for something, okay, let me use.
Hello, sir. Hello, sir.
Yes.
Before you go on, please, let's do something. I want to check something. The color you've used R, you've used B, you have used green, G. I think it changed to others. I think it only recognizes the primary colors, the initials of the primary colors. Please use W, let's say, or use B. B is blue. R
R is red, G is green.
R is red, G is green, but it's not recognizing P as pink or purple. Is it because those ones are secondary colors or what? That's my thinking of.
Okay. I'm not sure it is because they are secondary colors. I think it's basically
My
because,
thinking is that P represents pink and purple, so we cannot differentiate either of the two.
yeah, something close to that, or most probably that some colors have been specified with certain short forms, especially when they don't have multiple um, multiple referring colors. For instance, C is seen as cyan here, and there could also be probably another color. If I write O, for instance, O is not identified, despite O could have probably been orange. So all of those ones. So it's, for me, I always advise it's better you write um the name of the color you intend, because it could mean something else. So
Thank you, sir.
let's put this one as, let's say, green. So so now in our line chart here, we can also state the colors, right? So we can inside here just say comma color, and we can say color red, and it goes and it shows us color red. If we go to our chart here, we can also see certain things like the yeah the style of the chart we want, right? So for instance, we come inside there and we say um, I want my chart to be of let's say comma style this. Okay, so it says style. Let me remove this and do it all over again. So this is just so I say here
Check your style.
it's correct. It's
No,
correct. So something is
the
wrong
way
there.
you wrote the style is not correct.
Okay, let me copy this. Okay, yeah. Says cannot pass color Okay. Okay, yes. So we have a line chart with broken lines. We can
So
also,
the styles and the color cannot work together.
yes, that was why he gave us that the um this style and color cannot work together. So meaning we can have like I can have something like let's say not something like this. I'm not sure. No, this is not the style I want. So let's say I have I think kinds. If I come to kinds and I have I think oh there is a I'm coming. Okay, yes, I can have a style in my style and I have O's, so 00, so it sees everything as dots, dots, dots. This can look like scattered plot, but it's just a different one. So I think, yeah, so it doesn't see OO, but it sees O. So these are some of the um, styles that we can create while we format our chart. So let me just put this as chart formatting. So same way we um, downloaded the other one, we could literally download this chart also, just to show the pattern of um, flow or pattern of order that we have. So if we go to the next one, same thing we can do here also. We can use PLT. So let's use PLT. So we can have PLT dot X label, and then we put our X label as month year. Same way we have PLT dot Y label, and then we put this, and then we have PLT dot title. Then we put uh, best
Please,
PLT.
why are we using POT?
Yes, so like I said, um, PLT, which is Matplotlib, is the one that has the extension for us to add title to our chart. So if I have, so let me show us something. Let me go here, for instance. If I have sales data, right, I can plot sales data. Now in my plots, if I look at what I have inside plots, I have different parameters. Kind, I have AX. If I want to have like axis, I have subplot. I have all of this. Now I have title here also inside this plot. I also have X label and Y label. But by the time I run this, for instance, kind equals plots, let's say bar, and I run this, I'm going to have a problem doing something like this because this is a whole lot of data. And as such, for me to be able to visualize it properly, I would need to have created like segments, the way we used the group by function to create the analysis. And I would also have to state each part of it. So by saying title equals, I put my title sales data. Then inside it also, I have X label, equals to, I have y label equals. So all of these are features that I can have inside my pandas plots, right? But I decided to use the PLT because it gives me the opportunity to combine the feature of Matplotlib and the feature of pandas plot itself. Sure, we get it. It's not like we cannot come inside here, for instance, cannot come inside here and say kind equals plot, title equals this. We can do all of that, but here we'll be able to use Matplotlib much more better by combining these two. But we can visualize them and see how each of them handles each data. Also, you see with this now, this is taking so much time to load because I have huge data that I am plotting. But with Matplotlib, it's very much easy. And even when there is an error, it would automatically plot the structure of the chart itself. And then we can continue working. I want to terminate this. Okay, I think it's almost done. It's taking so much time. So I've shown us how we can do some of these labeling and formatting on using through Matplotlib. So how could we use do that on a tool like Plotly? So for a tool like Plotly, Plotly also has the feature sorry, I want this to load completely so we are able to see what happens. This guy is taking so long. Then it's understandable the columns and data that we have is because of
Can we just terminate it? So far, we've already gotten your explanation.
Yeah. Okay. Okay. So so let's okay, yes. So let's now go to how Plotly handles visualization. Now we see that by default, Plotly has identifies the column based on group by that we've done, and then it has value added to this side, then variable to this side. Now, but when we come inside it, we are able to see all of the columns, I say columns, attributes that we can have inside PX. Now, the ones that speak directly to title and labels are title. So title exists inside. Also, label, there should be label. Yeah, labels also exist. So we can use title and labels inside. And how do we use them? So when we come down, we can see here, it says edit with string key and string value. So it means that for us to use labels, we have to state using a dictionary to state the key and the value. So by default, it is empty. So it says column name are used to figure the axis title, legend, and all of that. So by default, it uses the column name to identify it. But if there is no column name, it just leaves it as empty. Then the title, it says the figure title. So let's now go here and see how we do that. So I put a comma, I say title. I want to make this thing come down. So I have title equals, so what is our title here? Monthly, let me make it capital letter, monthly orders. So when I run this, we are able to see that we now have a title called monthly orders at the top here. And so let's now go to the next thing, which is labels, right? Labels. So how does it say we use labels? It says we use a dictionary. So a dictionary, and we state our key. So our key and value. So the key is this part, this low part here. The value is what we have here. So what is our key? Our key is let's just say order months, and our value is orders. So when we run this, what do we have? See, does not, it didn't change. It's supposed to change. So yeah, labels. This is supposed to change. This is supposed to change by default. Okay, this is supposed to change, but I don't know why it didn't change. It was supposed to change the value we have here and the X label we have here. But since this didn't change, let's try to see if we can do this with Plotly and see if it will work. So let's say X label. So we've done something like this. So let me just go to the top and copy. So we do this and we run it. And here we see here that it created a order and month here, but it didn't work with Plotly. So this shows us that we cannot use Plotly and Matplotlib together as compared to using Matplotlib and Pandas. So how then do we fix this? So let's go to Plotly, so Plotly X label and Y label. So we go inside Plotly. So we see Plotly has its own, or what's it called, its own documentation website also, just like Pandas and every other one. Like how we are supposed to do that. Okay, what we're supposed to do is we're just supposed to say X and Y. So this is what we're supposed to just use, X and Y. So there is a problem. 1 minute. When we come here, no, I do not trust this. I do not believe that this is what we're supposed to do. No, I don't trust this. I don't trust this. This is the title. I don't trust this. Aha. This is what we're supposed to have. X label, this. Yes. Aha. Labels is what we're supposed to use. Aha. I said I did not trust it. I know what I was saying. So what we're supposed to now have is X label here and title here. But why is it not working? Manually specified label. So we see here now. Oh, okay. Oh, I was the one that made mistake. I figured it out. So what we're supposed to do is for each of the columns, we're supposed to have its own what's it called? Its own label attached to it. So what we're supposed to have is labels, and inside our labels, we would say this month here column, it should be other month, and the other column, other number, it should be others. So when we run this, okay, so we see now that other months has changed from here, but the other one didn't change, so we have values. So let's change this to values and see if this changes. So it says value is not defined. How then are we able to undo the other parts? I'm confused. Okay, so let's say value. All right, yeah. So now we see now that we have changed our value to others, and we have changed our month year to other months. So this is the way we are able to perform labeling on PX. Now, another thing we can also do here is we can change colors. So we can state the color that we want. And so we can come here and say color, and we can give any color we want. So let's say can I do this? It says greenish orange is a problem. It does not identify greenish orange. So let me use orange. What's the problem? It says value of color is not a colon in the data frame. Color is meant to be the color of our chart. So why are you having a problem with the color? So let's come back here and see what exactly is color. So it says color, either a colon of a, either a name of a colon in data frame or a pandas. So it means that the color has to be a column that we are referencing here. So this is not what we want. So let's come back to Plotly and say Plotly sets color. So how do we set color? So here we see, no, this is not what we want. This is not what we want. The color is creating color from sizes. We want to state a specific color. Okay, for us to be able to state a specific color, we will have to create something. What's going on here? we'd have to use color codes. We'd have to use color codes. So let's see. It still doesn't identify this. We want to change our color. Why is this thing stressing us now? Okay, so for us to actually change colors, we would use color discrete sequence. That's what we're supposed to use. So you're supposed to use color discrete sequence, and we can set the colors that we want to use inside. So we have this. So we have color discrete sequence, and inside it we say the color we want. Oh, I didn't put it in square brackets. So, and it has to be inside square bracket. So these are the ways to set colors in Plotly, and how to do some formatting also. So then here we can also download what we have. So once we download it, it automatically downloads, and it goes to our download folder. That's the one of the challenges with this. It goes to the download folder, but we can move it to our own location. And also, it's unlike when we download the image, it's the one that would give new plots, all of that. Like it's basically just says new plots, and then it gives it number and all. Hope we get that now. So this is what we use in modifying the colors. What happens when we set multiple colors? Now we can have multiple colors, and when we do that, it basically doesn't change anything. But multiple colors would be able to work when we have legends, or when we are using, we have a column that has multiple variables attached to it. So these are the ways that we can use this to work. Now, how do we modify line charts, for instance, and we would be able to do other things? So let's say we have so let's say we have a line chart and we want to modify it also. We can come inside there and see the things we can do. We can set the line dash. So if we want line dash, for instance, and what exactly does line dash mean? When we go, it says either a name or colon. So the same thing happens here when we have to state the colon we want to use for our line dash. But we can just literally come here and work with, let's say, format line charts, and we can see the different things we can do to our line chart. So we have just one straight line here. If we have multiple straight lines, multiple countries that we are looking at. So we see here now, it creates color for each country. If we have to state colors, and okay, so say yeah, so this what other thing can we do with line charts? We can set, okay, yes, we can add text to our chart. So for instance, we need to have txt equals so yeah, so here now we see our numbers added to each of the lines that we have. Sorry, was I supposed to do this immediately? So we see what we have here, but when we run this and add text to our line chart, we are able to see the charts better and understand that, okay, we had something here. If not, in situations like this, might not be able to identify that, oh, this is a sale for a particular month. But with the chart and with the text assigned to it, we are able to see the values better now. Another thing we could add is what other thing can we have here is marker. Yes, we can have markers. So instead of having just text, we could have markers, and we can say marker equals 2, so that instead of having specific values, sorry, markers, so we are able to see each marker for the values, the data that we have, basically. What other thing can we have here? I think we should be able to have okay, yeah, I think so. These are some of the things we can have. Then okay, yeah, we get there. Okay, so now these are some of the things we can have with the charts that we've done so far. We can also have colors for this. Yes, we can also have colors for our charts. So we can have color discrete. So let me put our color red. So now let's go to other charts that we can so other visualization charts that we can have. We can have pie charts. How are we able to use pie charts, for instance? charts. So for pie charts is used when we have a little number of columns, right? For instance, we want to have, let's go to our data. We see our data have various grouping like status. So under status, we would see that we have very few statuses. So we come to sales data dot, sales data status. That's unique. So we have shipped, disputed, in process, cancelled, on hold, resolved. Now, if we want to look at the, we want to visualize this type of data from all of what we have. So we can say that sales data, right, dot group by, open brackets, we have status inside, and then we say we want to look at all of the amounts we have generally, the total amount we've generated. We want to look at the sum. So when we run this, sorry, what does it say again? It says date time does not perform sum operation. Okay, so which date time column is it talking about? Aha, okay. Remember the other time we talked about creating copies and backup for whatever we have. Now, there is a table that is causing a problem for me, and I don't know which table that is. But let me say that I want to do this one. Okay, I want to look at sales. Okay, then I can have sum. All right, so I have grouped by, I have grouped my sales based on statuses. So from all of the sales I have, I see that the different statuses that we have, cancelled is 194,000, and all of this is the distribution of what we have from group by. Now, when I want to plot this, I can basically just do two things. I can just say this dot plot, or I create a variable and I say let's call this sales status. Sales status equals to this, right? So I come in and say sales status dot plot. What do I have under sales status dot plot? I want to have kind equals to pi. So when I run this, it creates a distribution of the sales that I have so far. And we see that this takes a whole bunch of the distribution. So let's visualize it somehow another way. So let me just change this kind to, let's say, bar, so I'm able to see some things clearly. So if we look at this here, we see that large amount of the product, or of what we have, okay, large amount of what we have in terms of amounts are being shipped, but this wouldn't be a very good visualization. So let's change this to count. So we are able to see a count of the orders that we have and how many of them have been shipped and how many of them have not. So when we run this, we see that it still takes like a whole lot. So a whole lot of the products that we have been shipped. But how then are we able to visualize this much more better when we have, or when we use
maybe we should use donuts.
Okay, yeah, maybe we should use donuts. But unfortunately, Pandas plot does not have donuts. So if we come here, for instance, and see some of what we could have in terms of kind. So we see that we have, so let me extract this. So if we look at all of what we can have, all of the charts we can have in Pandas. So Pandas plots. We have so when we look at Pandas plots, these are what we can have. We can have line, we can have bar, we can have bar H, which is the horizontal bar. We can have histogram, we can have a box plot, we can have density, we can have pi, we can have scatter, we cannot have donut. And these are some of the limitations that come with the Pandas plot. Now, how are we going to restructure or what's it called? Reshape our pie chart to be a little bit cleaner. So let's come here and say we're changing this to pi, right? Now, in the features that we can have, we would see that in our plots, we can have what's it called? We can have something called auto PCT, and we can set this to, sorry, 1 minute. Can you see my screen, please?
Yes, sir, we can see it.
Oh, okay. That's one. Okay. So now we can make this better by using something called autopicity. And what autopicity does is we are able to get a percentage structure from our charts that we have. That way, we can see or visualize our charts better. So to do that, we would have percentage. We have the decimal structure we want to use. So we say percentage. We want it to be in one decimal place, and we put this in percent, and we put percentage in it. So when we run this now, we see that, okay, I was not supposed to do this here. I wanted to do it here. Now when we look at this now, we see that we have like the visualizations. So it tells us that 93% of what we have has been shipped, right? Now, on 93% of all of the orders we have has been shipped, and the other 7% is what it's trying to squeeze here. Now, how are we now going to split all of this to make it much more visible? So Python has something called explode. So with the explode feature, we can just tell it to explode. So when we say explode, before we use explode, sorry, we need to state what our explode is. So I want my explode to be a what's it called? a value or a distribution of each of what I have. So I have 4. Is it 4? So let me go back again and see. How many distance do we have? 1, 2, 3, 4, 5, 6. 6. So I'm going to state 6. So I say, let's say 0 0.3, comma 0 0.3, comma 0 0.3. Let's copy this. Comma, and then do this. So now I see here now that I have been able to bring out what I have, my, what's it called? My statuses. I've been able to like split them, but it's still not showing clearly. So this is the limitation that comes with the pie chart plotting with pandas. Now, but before we go to the other ones, what we can do here also is we can have a title. So we can say title equals to status, other status. So we are able to see what percentage of orders have been shipped or have been delivered, depending on the statuses that we have. So when I run this, we have other status here. Another thing we can have is, I think we can have, we should be able to have X and Y label. Let me see this. Yes, we can have X. Oh, we can have X label, but we cannot have Y label because we have just one axis, basically. So our label equals to status. It should be good to have a minute. Okay, yes. We have Y label, which is status. So here we see that all of our status is what we have here. But in my opinion, when we use pie chart, we really don't need any of the X or Y labels. Our title is enough because we already have a well-defined or explained, what's it called? Explained column. But we'll see here that we have sales still showing here. So what we can basically just do is just make the label empty. So there is nothing inside and it is much more cleaner. Now, when we go to, sorry, I have to move this cell. I want to take it to, so let's now use another chart to another library to visualize the same distribution that we've done for the status column. Now, one of the libraries we have is Matplotlib, and we can see how Matplotlib handles what's it called? Handles visualization. So here it says, give me the X and all of the other things that we have here. So let's just copy. Okay, we are using, this is our column, this is what we are using. But let me just use this. So we have this. So when we run this, we see that Matplotlib plots different things, and then we have something like this. So it generates the same visualization that Pandas would give us. Basically, no much difference in what the two of them did. But the only thing is that it didn't state any of the statuses that we have. Now, we can then go in depth and say, okay, explode.